Number 11, represent the inverse. Okay, what happens with inverse functions? The x and y switches. So 11's going to be like the easiest problem. All you do is switch the x and the y values. So where it said 2, -6, guess what? -6, 2. There was another part to this problem, but we get -6, 2, 7, 1, 8, 2, 9, -3. Okay. Inverse just means x, y values are inverted. They're switched. The second part of the question, what's the domain and range of the inverse? So you guys remember what domain meant?
The middle. Left or right?
No. Well, what's the domain of this?
All
The x values. Yes, good job, David. The x values. On a graph, yeah, the x values go left and right, but it's the x values. The range is the y values.
2, 1, -3.
And then we're supposed to say, is the inverse a function? You guys remember how we did that?
Yes. If the x values don't repeat.
Yeah. Do the x values repeat?
No.
No, so you put yes, it is a function. Okay. 13. On 13, it's find the inverse, but we don't have to graph this time. But it is an x squared one, so it's kind of like number 10. No, just no. 9 and 10 are the only graphs so far. 13, f of x equals x squared minus 8. Yeah, we never did the asymptotes thing. Okay, so how do we find the inverse again? Switch the x and y. So we're going to put a y right there. How do I solve that for y? Plus 8. Then? Square root. What happens when we square root though? So that's basically a function notation would be that.
You square root it to get rid of the square, right?
Yes, square root gets rid of a square, or a square gets rid of a square root. They are opposites. What was the second question? Part of the question. Domain and range. So, do you guys remember what square root of x looked like? We talked about this yesterday.
Curved one. It's like
Yeah.
half parabola.
Yeah. Do you remember what's a plus 8 going to do to a graph? You guys know?
Move it left
Right.
8.
Left 8. So, it looks something like this. Well, a little steeper than that, but, you know, that's looks something like that. And then the negative version, that's the positive version. The negative version would be down here. Okay, so the question is, we're not actually supposed to have to graph it, but what's the domain?
X is -8.
Greater than or equal to -8. That's the lowest x value. So x is greater than or equal to -8. What is the range? How far up and down does it go?
All real numbers.
Yeah, forever. It goes forever up and forever down. So all the numbers. I think that was the last question, wasn't it? On that one. Is it a function?
No.
Is this a function?
No.
No. The inverse of quadratic equations, quadratic functions is never never a function, so we gotta put a no. So it's kind of got four answers, I guess, these four. Number 15. Graph and describe each function by stating its domain, range, y-intercept, and equation of asymptotes. We never, I mentioned the asymptotes, I'll mention them again, but I'm not going to make you do that on this. How do we graph that? Y equals 1/3, 3x plus 1. How did we graph this stuff? What did I make you do? You guys remember? Plug in. What did I have you plug in?
0, 1.
Yeah, -2 to 2, those numbers. Do you guys remember what shape the 3 to the x graphs made? Like these kinds. If you keep multiplying by 3 over and over, it gets, that's basically what's happening. It looks something like that. If I plug in -2, right there, -2 plus 1 is -1. 3 to the -1, 1/3. 1/3 times 1/3, 1/9. If I plug in -1, right here, -1 plus 0, or 1 is 0. 3 to the 0, 1 times 1/3. I plug in 0 plus 1 is 1. 3 to the 1 is 3. 3 times 1/3.
What's the end of the 9 weeks?
Like,
It's the beginning of spring break, right?
yeah,
What week are we on? 5th or 4th?
I don't know. Might be 9 weeks or 10 weeks. Sometimes there's a 10-week for third. Okay, anyway, if I plug in 1, 1 plus 1 is 2. 3 squared is 9. 9 times 1/3. 2 plus 1 is 3. 3 to the 3rd is 27. 1/3 of 27 is 9. So you might put your x-axis like that, because all the y values are positive. But it does have to go up to 9. So, make it nice and tall. -2,
Oh, we're actually graphing?
1/9. -1, 1/3. 1/3. 2/9. So it starts getting pretty big pretty fast. You guys have the graph paper from me yesterday? Yep.
Yes, I do, Mr. Jordan. Yes, I do.
Where are you talking about? Yes, I do. Yes, I do.
Because he's cool. Dang.
I just say that.
Okay, we need the domain, the range, the y-intercept, and then we'll talk about the asymptotes. Okay, what is the domain? Are you guys done? What x values work? How far left and right does it go? Forever. So it's all real numbers. What is the range?
Y is greater than 0.
Yeah, it approaches 0, like how low it goes, but it never quite gets there, so all y values are greater than 0. What's the y-intercept? Yeah, right there, across the y-axis at 0, 1. Okay, I mentioned the asymptotes once, but we didn't do it on the homework. Let me mention it again. The asymptote is the line that It's the line that the graph approaches but never gets to. So horizontal asymptote. Sometimes there's vertical asymptotes.
So do you want
But this would be y equals 0, like this blue line. No, but I didn't make you guys do that, so I'm not gonna make you do it on 14 either.
I'm writing. Thank you. I have a question. What's your favorite fruit?
You asked this question once before when you were stalling for time.
You ask it on
I'm
the
stalling for time. I'm just asking for.
You ask it all at the wrong time.
I'm just kidding.
Actually, I'm kind of curious too.
Or you're trying to get more.
Yeah.
Yeah.
Thank you. Thank you guys. So what is it, Mr. Drew?
Yeah, what is it?
It's a mystery.
Wow.
It's a honeydew melon, isn't it?
Okay,
There it is.
do you guys remember the compound interest? I'm trying to see if it's on the board. Do you guys remember the compound interest formula?
AT equals P
Probably should have put on.
plus R over K. R over K.
Okay, I am like 95% sure this is on the test, like number 2. Like, number 1 is like, what's the exponential growth formula? This one is on board. Compound interest formula looks pretty similar. Cadence, how dare you?
I don't know why her signature is on the thing. Me neither. My sister's a weirdo.
Or it's not failing.
Okay, so the K is how many times it gets compounded yearly.
Yeah.
How many times you get paid in a year. Alright. There we go. And this is just simple exponential growth. Okay. So on 17 we got $5,000 is our starting amount. So guess where that goes? Right in front. And then it says 5.2% APR, annual percentage rate. What did we turn 5.2 into?
It does. I mean, if, no, that's not.
Okay, 5.2% equals what?
0.052.
Yeah. 0.052. You gotta move the decimal back a couple times. So it's 0.052 over. Okay, it says compounded quarterly. How many times a year is quarterly? 4. So we're going to put a 4 there for the K and there. Usually we leave T as a variable, and then sometimes it says how much money you're going to have after 10 years or something like that, and then we have to plug it in.
What is continuous?
They do say in the directions that we have to figure out how much money will we have after 15 years. So this is answer number 1, that formula. And then answer number 2 is we plug this in the calculator. What'd you say? Continuous?
Yeah.
It's the E thing. Oh, look you guys what that is. That's number 19, yeah. Quarterly means like 4 times a year. Sometimes it says monthly, that's pretty common, and that's 12 times a year. Quarterly is 4 times a year. Daily would be 365 times a year. And what's another one? Semi-annual was the other one. Semi means half, so twice a year. Anybody plug this in the calculator? We're talking about money, so you probably want to round it to the,
10,852 and 67 cents.
say again, 10,008?
852 and 67 cents.
Okay. You probably want to round it to the nearest penny.
Yeah.
Okay. This formula I mentioned on Wednesday, this is like the most recent assignment. I'm not gonna have you memorize this one, but this is for continuous interest. We didn't use it on Wednesday because kind of ran out of time, but you just plug the numbers in. P is still the starting rate, starting. You guys remember E on your calculator, right? E to the X. R and T are still the rate and time, so that's the only, you just plug stuff in here. So 19, 25,000 compounded continuously, so it's 25,000 times E to the, okay, what's 3.9% turn into? 0.039. And I'm gonna put a little T right there. That's the first answer. The second one is how much money are we gonna have when T is 15, after 15 years. So we just plug in all this with the 15 in the calculator.
Do we all need to know this one for the?
No, I just said no, you don't have to have this one memorized.
44,874.
Is this compound?
This is called continuous compound, 44,874.77.
I'll tackle the money stuff.
Don't.
It's a lot. I'd rather do easier problems that are very long. That makes sense. They're really hard.
These are not
Just plug in the
Is 18 large?
I got 32 something. I mean 42.
This is-
Freaking 40.
We would have the time to do this.
Huh?
We would have the time to work on this.
No. We're gonna go to the end of the page here.
And then we work on
All right,
Is
yeah.
18 supposed to be large?
Eight.
Is it smaller than
They're
that?
going to 30?
It's over 40,000. It's about pretty similar to 19,
Okay.
Well, then I probably did something.
evidently.
Because
Always.
I got over 3 million.
Okay, did you change it to .0624?
But how much are we here?
Did you divide by 12 and put 12T?
Yep.
Okay, I
How
don't
many
know.
zeros did you put on the 70,000?
2.
There's supposed to be three.
17,500. So there's 2 zeros.
I don't know. Just try plugging it in. Try plugging it in again. Yeah, maybe you
You probably did.
just hit the wrong buttons or something. Okay, 20 is 10,000 black bears increased by 2%. So what formula are you going to use for that? Okay, just the exponential growth. That's not compound interest. That's just normal growth. So 20, you can just use this formula. Okay, 21, we use this formula like twice. It's called the half-life formula. And no, you don't have to have this one memorized either. You guys remember the half-life thing?
Yeah, is it exponential decay?
It's like decay, yeah. It's pretty similar. T is the time, but H is the half-life of the thing. So we just plug the numbers in again. Half-life means how long before it's half of what it was. So, like if the I don't know, population is dropping like every 10 years, it's half of what it was. 10 years would be the half-life. Anyway, the half-life of a radon 222 is 3.8 days. So 3.8 is going to go where the H is for the half-life. How much 300 milligrams of isotope remain after 8 days? So 300 is the starting amount. And we're going for 8 days, and the half-life, that's the time, and the half-life was 3.8. I think they just want us to plug that in. Oh, no, these questions, 20 and 21 have a lot of questions on it. So the first question is, what's the initial amount? 300. Actually doesn't ask that. It says, state the growth factor. What's the growth factor? It's this number in parentheses. So it's 1/2. What is the percent change?
Wait, so we don't have to do
50?
Yeah, you do have to do this. Yes, we do have to answer this.
Okay.
Well, it's not just 50%, it's dropping 50%, so, yeah. It's kind of like 1 minus 50% is 50%, right? So that's why it's a half right there. What's percent change? And then answer the question. So yeah, we do have to plug this in. This is supposed to be an exponent. I didn't write that very well.
Oh. So,
Point
91.
What'd you get?
0.31.
No.
69 milligrams.
69.7.
Is that calculator broken?
Yes.
Well, this is an exponent, and you're gonna have to put it in parentheses on your calculator.
Calculator never fails.
Well,
Until they do.
I'm sure. Got it.
Yeah. So these are the 3 answers.
Okay, I got that.
Got it?
so is the second answer at 22%?
Is what now?
2%?
Yes. All right. 23. This is the part of the chapter I like the most. 7 to the negative 2 equals 1/49. So this is a true statement, but the question is, how do we write that as a log?
ACB.
ACB. So it's log what?
Log,
Seven.
Log little 7 of what?
149.
Equals
Negative 2.
negative 2. You guys have this in your head yet?
Yeah.
I think I
Stuff it in there.
Oh, that's what we're doing, 23 and 2, right?
25, yeah. Remember, some of this chapter was easy. Not all of it was hard. Natural log 7.8, 2.0541.
So ABC.
Yeah, same thing. Okay, well, kind of the same thing. We're going from log to exponent on this one, but it's still ACB. Okay, so what do I start with? What's the invisible base right here?
E.
E. Yeah, 10 is an invisible base on log. It's called a common log, but this natural log didn't. Okay, and then what do I put next?
2.
This thing. A, C, B. But where does this thing go? Exponent. That's kind of a weird exponent, but whatever. And then what?
Equals 7.8.
Kind of hate to do it, but I think the test's going to be on Wednesday. So hopefully we don't get here late.
You may get here.
If we do,
Thursday.
I don't want, Thursday's even worse than Wednesday, but if we're late, we might have to.
Chapel.
Like because of chapel, yeah. I gotta, what's it called? I don't think
Why is Thursday
Huh?
worse?
Because it's Wednesday night, the night before. So, well, just be ready by Wednesday and then you should be good, hopefully.
What if we just take a
Some people might want to study. And you're not supposed to have homework on Wednesday night. Alright, 27.
What if we
Long.
just do it on Friday?
No. Okay, so we're supposed to solve this like equals what? You can just plug this in your calculator, but Will, do you remember how to do this on your calculator?
Probably. I do. You do.
Is log of 1/625
Yeah.
divided by log of 5.
Yeah.
Log.
Yeah. So if you have kind of a basic calculator, yes, you can do this. That would give you the answer too. And it says round, no, it doesn't say round. Well, it looks like on 29 they rounded the 4th decimal place. Everything else comes out perfect. Okay, if you have a nice calculator, you can just plug this in. If you have a more basic calculator, you can plug this in. Did you guys try 27?
Yeah.
Should have got -4.
Yep.
Yeah, 5 to the 4th is 625, so 5 to the -4th is 1/625. And then 29, same thing. This was like the Friday assignment that everybody got like almost 100 on.
Remember that?
Okay, I'm gonna pause there and we'll finish this on
Hey, you said after 30.
Monday.